to the mouth of the Delaware Bay. In the upper bay, well, let me say these three sites were formerly diked salt hay farms. So what that means is that the previous owners had a berm all around the site, and they excluded the tide. So that they were artificially propagating salt hay, which is Spartina patens, testiculus spicata, at an elevation lower than it would normally grow, because they could exclude the tide and regulate when they flooded the marsh. And what they would do is they would flood the marsh in the winter, let some salinity in and germinate, invigorate the Spartina patens, and then they'd let it drain in the summer, and then they would go out. I think we have a picture in our handout, and they would mow that salt hay basically with regular baling equipment. And salt hay is very good mulch. It used to have a huge market for mulch before they started using plastic mulch. Kind of replaced it. But the reason it was such good mulch is because there's no weed seeds in it. Like if you use regular straw, when you're starting a lawn or something, you get lots of weeds. But salt hay, coming from the marsh, has no other seeds mixed in with it. So these three sites were formerly diked. So there was a little different restoration history, and we'll get into that in a little more detail. The upper bay sites, of course, we have the Clancy River Wetland Restoration Site, the Alloway Creek Wetland Restoration Site, where we're going to visit tomorrow. And then in Delaware, we have the Rocks and Cedar Swamp restoration sites. These 4 sites, plus 3 more that we were working with the state of Delaware on, are Phragmites-dominated marshes. So these marshes, they'd have a dike around them hundreds of years ago, but those dikes have long gone, and now they've become invaded by the European strain of Phragmites australis. There is native Phragmites, but in this case it's a European strain. It has no competitors. Very vigorous. It outcompetes all the other native marsh species and takes over the marsh plain. So and the restoration process here was a little different. There really wasn't any excavation or digging like we had here on the Marsh River Township site. And we'll get into more of that detail tomorrow. So we're kind of doing this a little out of order. Just to kind of orient you on the bay shore here. So this is the Marsh River restoration site here that's in red, and we're here at the observation platform. And of course this is the Delaware Bay. The commercial township site this is the Morris River, so we're going to go across here to the commercial township site. It's on the other side of the Marsh River. So this is another formerly dike site. And this is our largest site. It was about 3 miles across and 1.5 miles wide to the area that we introduced.
1,700 hectares.
Yep, 1,700 hectares. So this is a huge site. This site is how many hectares, John? 1,000 acres is. Is it on here?
Or it's in the handout.
It's in the handout. And then the Dennis Township site, we're probably not going to be able to visit today. This is our smallest site. It was the first one where we introduced tidal flow in 1996. We introduced tidal flow to this site in March of 1998, and then this site was in November 1997. So these sites now were, pushing 15 years beyond when we first reintroduced tidal flow to the marshes. Just to kind of orient you. The other thing we're going to visit right between the Dennis and the site where we are today, the Marsh River, is what we call the Moores Beach West Reference Marsh. And this is an area that historically was diked, but the dikes went out naturally in 1979 through 1981. So it's kind of self-restored, and what we're using as a reference marsh because we compare our vegetative cover, the marsh functions on the restored marshes, to the reference marsh. So we do the same monitoring on the reference marsh that we do on the restored marshes. You need something to compare it to because, how do you say whether the restoration has been successful? In our case, we're using reference marshes. And we have another reference marsh up bay with the lower salinity up in the oligohaline portion of the estuary for comparison to those Phragmites-dominated sites. Jump in here, Brenda or John, if I'm missing something important. Okay, so this is the Marsh River Township site, and a little bigger blow up for you. This is the observation platform. Oops. Just set that one in front of you here. This is the wetland restoration design. We went through a rather detailed engineering process in order to come up with what we ultimately implemented as a restoration design. You remember these sites were diked, so they had a berm all the way around them, no tidal flow. This was very much high and dry with ditches in between, and there's a picture in the handout here of what it looked like. So there was no no function in terms of providing food source to the estuary, no access for fish, for habitat. So it was really...
Where it says Thompson's Beach, 100 years ago, there were 3 streets and a whole bunch of houses.
Yeah, you see where we are here, there used to be a road that ran all the way out to Thompson's Beach. This was a beachfront community until the hurricane of 1950 came along and wiped out those houses.
No, we are here.
Yes.
So there's a road, you can see a little bit of it here. Now the road's mostly covered by Spartina. It's straight out where you see the little dip.
It starts out here.
Yeah, you see the little dip in the Phragmites, which is a berm on the back side of the beach. That's where the road goes up onto the beach here. So this is pretty typical of the Delaware Bay shore communities. They were thriving resort areas up and down the Delaware Bay back in the 1920s, 1930s, before there was modern transportation. They were easy for people to get to from Philadelphia metropolitan area. People would have a summer house here on the bay. But due to the shorefront erosion that's occurring all along the Delaware Bay and coastal plain subsidence and then those storms, most of those beachfront communities are gone. There's a few of them left where people have summer houses, and you can pick up some bargain property if you want. But there is a problem with
you can see it up there. See the houses?
Oh yeah. Yeah. This what you're looking at up here is at the
Where?
it's on here. If you right at the mouth of Marsh River is a place called East Point, and there's actually an historic lighthouse. You can see the cupola on the lighthouse through the trees. You see the little rounded dome with the cupola on top. So this is East Point. We'll go by that. This is one of the remaining beachfront communities as well. So the basic restoration design here, we looked at the adjacent reference marshes, and we had other marshes we looked at as well. In a natural marsh, how many creeks do you need? What's the depth? What's the cross-sectional area of those creeks? Because you want the marsh to fully flood and drain on each tide. So, and we based the design on the adjacent marshes. So we know how many feet per acre of channel there are in those marshes. We know the depth, the cross-section. And then we had detailed topography for this site as well. We did digital terrain modeling to get plus or minus 6 inches of the topography, because topography is key when you're dealing with a 6-foot tide, because you want to get at the right elevation so that you have 9 to 12 hours of hydro period each day for Spartina ultiniflora to grow. So using that hydrodynamic modeling, where we could try trial and error method to see where the creeks should be. We looked at where they were historically. We can look at how large they need to be, and model different locations till we came up with a design that would fully flood and fully drain the marsh on each tidal cycle. Basically, you have 6-hour flood, 6-hour drain, and you need all that water to run out. And then one thing we tried to do on most of our sites, we tried to avoid bayfront inlets for our tidal creeks, because you have trouble with those inlets closing, you get a lot of erosion, wave fetch. In this case, there were some natural channels that developed on the bayfront, so we incorporated those into the design. So we basically have 4 channels. We have channel 1 that comes off of Adler's Ditch over here to the west, where you see that tree line. That's Adler's Ditch. We have a bayfront breach straight out in that direction where you see an osprey platform sticking up. That's right at the mouth of channel 2. Channel 3 is on the south end of the beach where you see the Phragmites berm dips. And right just beyond that dip in the berm is channel number 3. And then channel number 4 comes in off of Riggins Ditch. We're going to go up Riggins Ditch. This is the reference marsh on the east side of the site. We excavated primary channels, the largest channels, first and second order channels coming from the bayfront, and then we let ecological engineering, Mother Nature, decide where the rest of them need to be. We did incorporate the existing ditches that were in the salt hay farm that drained the salt hay fields. You can see one main ditch that's running east-west across the site. And so these areas were hydraulically excavated with a hydraulic dredge. That material was then pumped into these containment areas. We constructed containment areas for that sediment that was excavated, and these were designed to become high marsh. So we didn't want to create upland. We wanted to stay marsh. So we designed them so that they would flood 4 or 5 days a month and become high marsh. So we'd have some remaining Spartina patents to stick the spicata these high marsh species were designed to grow on these areas. So this material was then pumped into these containment areas, and the trick was trying to get them to the right elevation for high marsh, because you don't know how much they're going to subside, you don't know what the moisture content of the sediment is. It's like any dredge project. There's a little bit of an art there as much as it is science. How high do I pump them so 3 to 4 years from now they're going to be at the right elevation for a high marsh? And in some cases, you know, we got them a little too high, and we did a little bit of leveling on this one in particular to get it down to the right elevation. In terms of restoration status, well, there's one other unique aspect of this particular site. Of the 3 dike salt hay farms, 2 of them we did the construction in the dry. So the historic berms around the salt hay farm were intact. We were able to keep the tide out, just let in enough water to dredge, so we were not working in a tidal situation. In this case, the salt hay farmer stopped maintaining these berms, and they breached to the point where we couldn't repair them. So this site actually flooded with water for 4 to 5 years before we began the restoration. And it would flood with water on high tide and then would be unable to drain because there was no creek channel network established. So it was ponded with water for 45 years, which killed all the existing vegetation on the marsh. So when we implemented our restoration and put the channels back in, then of course it drained as the marsh should, and would flood and drain on each tidal cycle. So it's a little different history, and you know, there's some subtleties associated with that affected the revegetation. But this is what the vegetative cover looked like pre-restoration in 1996. You see the gray is mudflat. It was starting to drain at that point because the breaches occurred in 92. So in 96, you can see most of the vegetation was killed. The green is some remaining Spartina alterniflora. And the yellow one here is some Phragmites australis. What happened when these salt hay farmers, they had the hydrology very disturbed, so this Phragmites was invading their salt hay farm sites, taking them over. In some cases, particularly at the commercial township site where we're going to go to later today, about 40% of that site was covered with Phragmites. In this case, there's enough salinity in the bay down here that salinity will control Phragmites once you reestablish tidal flow. So we didn't do any treatment on the Phragmites here, but let the salinity and the tidal flow control it. So 96, pre-construction, and I don't know if there's a time series in the handout too, I think, of the vegetative cover between the interim years. But when you get to 2004, you can see the channels. Here's channel 1, here's channel 2, channel 3, and channel 4. You know, they stand out, look like nice creeks. And by 2004, the site had fully revegetated naturally with Spartina alterniflora. We did no seeding on these marshes. There's enough surrounding marsh to provide Spartina alterniflora seed. That seed would wash in the fall, would take set, and then the following year would sprout. So natural revegetation, and within 3 to 4 years, really, this site fully revegetated. There's a little remaining mudflat. Some of that is due to the elevations. When you dike a marsh for hundreds of years, what happens is the marsh loses elevation. You have subsidence, compaction, oxidation of those organic sediments. You also stop accreting sediment. Marshes naturally accrete sediment. 3 to 4 millimeters a year is kind of a standard accretion rate, although we have some more data on much higher sedimentation in our restored sites. But as a result of that loss of elevation, some of these portions of this marsh were 1.5 feet lower than would normally grow Spartina. So we needed to accrete sediment. And in the case of the commercial township site, we incorporated provisions to accelerate that sediment accretion to get it to revegetate more quickly. So some of these areas are low. Some of them are also due to snow geese. In the winter, particularly late winter, we have tens of thousands of snow geese who winter in this part of the Delaware Bay, and snow geese are devastating on alterniflora. They actually pull it up by the roots. Unlike Canada geese, which just graze it, snow geese actually pull it up by the roots. So you end up with these bare spots, and then the geese will move on, and then they will fill in with vegetation. But on the whole, the site is nearly covered with vegetation. We did stop monitoring this site in 2004 because we met our success criteria in 2002. In terms of the cover, you can see in 1996, the green line on here is the Spartina alterniflora. It was well below 10% when we opened the site up. by about 2001, we were up above our success criteria. As part of the program, we have established success criteria that are in our agency permits, and basically that's what this dotted line shows here. The success criteria said that in order for the restoration to be deemed complete, you needed 80% coverage of the marsh by spartina, altiflora, and other desirable species. For the Marsh River Township site, they did lower the bar a little bit because this is a very good birding spot. You know, whether you're restoring for fish or whether you're restoring for shorebirds, you have different objectives. We were restoring primarily for fish production, but there are a lot of birders who wanted to see mudflat. They don't necessarily want to see spartina because it hides the shorebirds. So they set a little lower bar for this site, actually 76%. No, 66, right? Mm-hmm. For this site, as relative to the other sites. And of course, this is the yellow bar is the Phragmites. You can see we had close to 10% on this site, and it dropped as well with the reintroduction of tidal flow. And then the gray line on here is the non-vegetated marsh plain, like you see here. And you can see as the spartina vegetation coverage increased, the mudflat non-vegetated marsh decreased. So the response here to opening up to tidal flow was very rapid. The vegetation took seed and it revegetated very quickly as well.
Do you have some information before 1996?
We have some pre-restoration. Of course, this is a pre-restoration vegetation map. We do have a little bit of pre-restoration fish data. I mean, these ditches did have killifish and other marsh resident species in it, but none of the transient estuarine species. We also did a little bit, in order to get our permitting process, we had to do an environmental impact statement. So we have some, a little bit of data in there that supports that environmental impact statement as well.
Oh yeah.
And the horseshoe crab spawning habitat. Try and get it back to nice sandy beach for the shorebirds and the horseshoe crabs. So you can see we're right here, it stopped 2. So this is the beachfront community. Here's one that had some houses on it. There used to be a whole series of houses. In fact, there were 3 rows of houses before the 1950 hurricane. But it's a very good area for shorebirds and for the horseshoe crabs. Horseshoe crabs nest at the peak of the tide in sandy habitat where they lay their eggs. And then the shorebirds, of course, feed on horseshoe crabs migrating through. A sharp edge here. Mm-hmm. Over time, those channels start to develop a more natural form.
How deep's the clay layer? Presumably the sand underneath all this, is there?
The sediments varied across the site. Some places we would hit a lot of sand when we were dredging, made it much harder to dredge. Other places there was deeper organic sediment and aggregate material. Yeah. So it varies.
Roughly, kind of a meter, 10 meters?
We dredge these channels down to about 2.5 feet below mean low water, so that's about 6 meters or so. Feet. And we did, in some places, we did hit stumps. So if you go back in geologic times, a lot of these marshes were white cedar swamps. And there's now 6 feet, 2 meters of sediment over top of those white cedar stumps. So we had trouble dredging where we'd run into those stumps. And you had to go in and mechanically remove them, particularly on the commercial township site. Ocean and then back to the Sargassum Sea where they spawn in their 3rd or 4th year. So it's a transient species, like many of the fish species here. They don't spend year round here. They come and go depending on their life history.
So perhaps the Murray for the year imports to a Quebec because Quebec like the year very
right.
much.
Well, that's yes. But they like the elvers, which are the young glass eels, which they catch in the freshwater streams, well upstream.
They're small.
And there's a big market for them. And the problem is that there is a decline in the eel population in the United States, and they've restricted that fishery for American eel. But these would be adults. And they were in here now, and I guess when the water temperature drops, they'll go back out into the Atlantic Ocean.
You can go over and look.
It's called a Secchi disc. S-E-C-C-H-I. I don't know.
slowly bring it up to differentiate between the white, the white side and the white and the black. And that's where you can measure. This has incremental marks on it.
Yeah.
That mark
marks like the black mark. Water
So 30 minutes. So they say
centimeters. But you know, they make fancier techniques, you know, light transmissivity meters and all that stuff. This is kind of fail-proof about this. Doesn't require any calibration. So generally, every time we take a trawl sample, I don't think you do it on beach stains too?
Yeah, we do it for
so along with the biological data, we get the physical-chemical data, water depth, water clarity, salinity, temperature, and they also measure surface, bottom, temperature and salinity. Is everybody ready for some open water, maybe a little splashing?
Everybody wants to keep things dry. We can always put stuff in there. There are life jackets in there, but we can take them out.
Yeah, if you got stuff that you don't want to get wet. I mean, you probably won't, but sometimes there's some splashing. Especially when Mike drives.
Let it go.
Okay, we're going to head down back along the Marsh River Restoration Site. We're going to go across the mouth of the Marsh River over to the Commercial Township Restoration Site. We're going to poke in a couple of the created inlets along the shoreline. Can't go in very far at low tide. If you want to see that site, you really need to get in an airboat, which is another experience. But we can only carry one passenger, so John's been in many times. And their boat's kind of a misnomer because they do sink.
Yes.
They don't float.
They're driven by an airplane engine. That's where the air comes from.
Yeah, we have one that's like an ultralight. You know what ultralight is? Where they fly off with nylon wings. That's an ultralight engine. All right. You also can take one of those cushions when we get out in the bay, and you can sit down there along the front if you want to. Top predator. I guess there's a restoration design. I don't think I have the design with us, but it's on the next couple pages later on there.
It's in the book.
Yeah, you'll see the restoration design. Go to page 16 in the handout.
Yeah.
You'll see the restoration design. You see channel 2E, and it had a number of channels that were excavated off the side of that. So this is all region 2E of the site. Because there is a 2-hour tide lag between the part of the site that's fed off of Inviting Creek and the bayfront, we broke the site up into separate hydrologic cells, which you can see on there. So there's a regional berm that divide the site into, I guess, 5 or 6 different parcels that each have slightly different hydrology, each have their own inlets, and these 3 or 4 are fed from the bayfront, and these are fed from the side, because we didn't want the water to rush across the site. Otherwise, we'd never get any vegetation to grow.
This shows.
Yes.
This is how it was eventually divided. That's the modeling of what would have happened if they didn't divide it.
Yeah. If you go back a couple pages later, page 20. 20 shows. Flip one more. You can see those are some just snapshots from the hydrodynamic modeling. This is what happens if you didn't divide it up into separate cells. You can see the red meaning high velocity. And you don't want high velocity, otherwise you don't get sediment deposition.
Means high sediment load.
Okay, that's the sediment model, not the velocity.
The arrow is the velocity.
We had 2 different models. One showed sediment, one showed velocity. Well, there are invertebrates in the mudflat, but eventually the root mat starts to die, and then you lose that too. So it's birds will feed on there, but it's a high energy area with the waves and the wind fetch coming across the bay. I mean, there's nothing wrong with mudflat. I mean, the basis for our program was make Spartina, which turns into detritus and feeds the detrital food web. I mean, again, it depends on your objectives. Mudflats are used by fish too, particularly fish that feed on benthic invertebrates. But our objective has always been vegetation, and that's our success criteria. Whether that's the right thing or not, but
我们
yeah,
呢
they help.
都是好东西啊。
是。
So big.
And John says they're good to eat too, right?
Yeah.
Mm.
Yeah.
Well, you have to spend a little time
They're not as good as blue mussel, but
soaking them.
Well, yeah, you want them to
See
you
mud.
want them to get rid of the mud inside before you eat them.
it adds a little grit. The birds eat grit.
Oh, we have birds will.
But I don't have a
I-
gizzard.
You don't have a gizzard?
I prefer not to.
I believe a
It's
second
just
order
happening
class
very
because
slowly
we had
up here
dredged
because
for maybe third, second or
We're so
third.
far.
We actually
from the
constructed
bay.
this particular channel.
A lot of the mud has already dropped out before the water gets up here.
So this one
So-
was actually
So this will take
one Teal's talking about.
a long
We put it
time,
after
but,
the fact because it just wasn't the green, Mother Nature wasn't.
we don't think we have to do anything
putting water off the
except
marsh, so we put some
uh,
in.
not let anybody dig it up.
But, it's just very slow developing up in this
I don't
area
think so
for
because
one thing, it's so far
it
from the
all
back,
has
it's
to
not
come in
getting
that
the
one
sun.
channel down at the entrance.